Welcome to this 12th video of lesson Similarity of Standard 10th Mathematics Part 2. In previous video, we have learned how to solve questions from practice set 1.3 based on similar triangles. Let's solve the next questions. Till now, we have solved 5 questions in previous videos. Now in question number 6, it is given that in trapezium ABCD, AB is parallel to DC. So this is AB which is parallel to DC. Diagonals AC and BD intersect at point O. If AB is 20, DC is 6, OB 15, then we have to find OD, which is written as X. Okay. So now here in the last video also we have seen that when it is a trapezium is given and the diagonals intersect, because of this, with these two angles form, we can prove them similar. Okay. So when we can prove these two triangles similar by a test, we can use corresponding angles of similar triangles are in proportion. Using that property, we can find the required OD. As we have seen in the last video also how to prove these two triangles similar, that when these two lines are parallel, taking AC as a transversal, we can prove angle C is congruent to angle A, because they are alternate angles, and angle D is congruent with angle B. So same reason with the alternate angles. And if you want to prove angle O, even angle O can be proved congruent with angle O, because this is vertically opposite angle. So either using all three angles and using a test, or in two angles we can use a test and we can prove these two triangles are similar. So let's start the answer. So here in answer, we will first write in triangle. Suppose we are writing the name of the triangle, say OAB, OAB, and triangle. For this upper triangle, the corresponding angle with O is O only. With angle A, the corresponding angle is C, and with angle B, it is angle D. In triangle OAB and OCD, angle A, let's write angle A by keeping some distance over here, is congruent with angle C. Okay. Now we have written this A in the middle position. So the remaining 2 points O and B we will write one to the left and one to the right of A. And for angle C, so we have to write angle OCD. Okay. This angle A and C are congruent because they are alternate, as well as angle B is congruent with angle D with the same reason, alternate angles. So angle B is congruent with angle D. So remaining two letters A, O and A, writing one to the left and one to the right, and here OC. Okay, now reason we are going to write it together, or both these pairs are congruent because they are alternate angles. Okay. So, using this reasoning, we can say that triangle OAB is similar to triangle OCD by a test. So, when these two triangles are similar, we can take its corresponding sides. Okay. Now, we have three pairs of corresponding sides. Let's take the two which we want. Now, OA. OA is not given and we do not want upon OC. So skipping this first pair, OA upon OC, let's skip it because neither we know OA or we do not want AC also. But taking now AB, second and third letter divided by CD is equal to OB. The CD and AB we want, and then OB and OD we want. OB is 15 given to us and OD we have to find. So it is OB upon OD. So these are the corresponding sides of similar triangle. Now let's substituting the values. AB is equal to 20, CD is equal to 6, is equal to OB is 15, and upon OD we have to find that OD. I will write OD or you can write X, and therefore OD is equal to 15 multiplied by 6 divided by 20. So it is 5 3s are 15, 5 4s are 20. If you divide this 2 by 2, 2 2s are 4, 2 3s are 6. So it is 3 3s are 9 upon 2. Therefore, answer can be OD is equal to either 9 upon 2 or it can be 4.5. Okay. So, this is your answer of OD. Now, after this question number 6, let's see what is question number 7. Now, in question number 7, it's given the figure that quadrilateral ABCD is a parallelogram. So, ABCD is a parallelogram. It means opposite sides are parallel. Point E is on side BC. Point E is on side BC. Line DE intersects ray AB at point T. Line DE intersects ray AB at point T. It means this is the collinear ABT and DET. These are the points collinear and they are meeting at point T. We have to prove that DE into BE is equal to CE into T. Where are these segments? Let's check it. DE, where is DE? This is DE. Okay, into BE. BE is this. Is equal to CE into TE. Okay, so we can see that this DE, BE, TE, CE, these are the sides of these two triangles CDE and BET. Now related to these two triangles, we do not have any property which can give us say A into B is equal to C into D. Okay, so we never have such property A into B is equal to C into D. But how can we get this product? If we have, suppose say ratio, say if we take C over here, A upon C is equal to D upon B. In that case, with the help of cross multiplication, we can get A into B is equal to C into D. Or if it is in the form of A upon, instead of C, it can be D and is equal to then C upon B. So if we can have ratio like this or like this, then also by cross multiplication we can get this property. Okay. So if we want the two products to be equal to other two products, then we have to try to get such ratios which are equal. Okay. So how and which ratios we have to prove to be equal? To prove DE into BE is equal to CE into TE. Suppose we are taking DE here in the numerator, to its denominator should we take CE or TE? There is a smart tip for you, there is a clue for you. Now DE, check it is in which triangle. Now DE is in triangle DEC. Okay. Now from this side, try to get such segment over here which is not in that triangle, not in the triangle where that DE is lying. Okay. So CE, if we take CE, CE is from the same triangle. So don't take CE here. Try to take TE which is from the another triangle. So if we can prove DE upon TE is equal to CE is here only now, and let's take BE on that side, so it will become division. Means to prove this, we will try to prove this first. Can we prove these two ratios are equal? Means these four segments are they in proportion. Okay, how can we prove this? As I told you, try to take such segment below this which is not in the same triangle. Means for this is the DE upon TE. So we have to prove this segment, this side of the first triangle number 1 with the and this segment of the triangle number 2. And here CE upon BE. Means suppose we want to take these two triangles and its sides we have to show in proportion. In which case it can be in proportion if they are similar. So can we show triangle DEC, okay, DEC similar to triangle this BET. But how we can show, what can be the correspondence? Now we can see that E and E can be shown congruent because they are vertically opposite. So if here it is E in the middle position, here in the middle position we can get E. Now what will be the correspond to angle D if we have these two lines are parallel? DC is parallel to AB. So angle D can be proved congruent with T because it's alternate angle. Okay. So D is congruent with T, and similarly C can be shown congruent with the B. These two are also alternate, taking these as transversal. So this is remaining here B. So we can prove angle DEC similar to triangle TEB by AA test. And when we can prove this triangle similar, we can prove this corresponding sides are in proportion. Okay, and when we get this ratio by getting cross multiplication, we can prove this required thing. Okay, so thought processes will go like this, but when writing we will do this in this direction. Okay, so first in answer we will try to prove these two triangles are similar. So let's write the name of the triangle. In triangle DEC and triangle TEB, we can prove all three angles congruent, but let's take any two. So let's take alternate angles. So angle D is congruent with T. Angle D is congruent with angle T. Okay. So what are how to write these three letters of this angle? So this D we have taken in the between. So the remaining is EC. So this angle is going to be EDC. Say EDC like that. And this T we have written in between. So EB will be written E and B, one to the left and one to the right. Now D and T we have taken pair of alternate angles which are congruent, and one more pair which is alternate here, C and B. So angle C is congruent with angle B. Here we have taken C, so remaining is DE. So the angle has become DCE. B we have written here in between, so TE. T here, E here. So by this way, let me rub this rough work part. And this reason is going to be alternate angles. Okay. Therefore, triangle DEC is similar to triangle TEB. Reason is a test of similarity. Okay. And now let's write the corresponding sides which are in proportion. DE. Do we want DE? Yes, we want DE. So DE upon this TE is equal to, do we want EC? Yes, we want EC upon this EC second and third. Here second and third is EB. Okay. Now do we want the remaining DC? No. We do not want DC and BT. That's why let it be here. So these are the corresponding sides of similar triangle. They are in proportion. And now by cross multiplication you can get it, say DE into EB. You can write it as BE as you require in the question. Now here EC you can write as CE into TE. Okay, this TE. So we have proved this, the required product is proved. Okay. Now whatever part, rough part I rub, you can write it with the pencil. Okay. Do not write that rough work part, thought process with pen. The main answer should be written with the pen, and the thought process should be, rough work part should be written with the pencil. So we have seen how to solve question number 6 and 7 from practice set 1.3. In the next video, we will solve the remaining sums from this practice set. I hope you have understood the sums and you understood the trick or technique how to decide which two triangles can be shown congruent and how to write the angles in an easy way. If you have liked it, please don't forget to give me likes and comments. And if you are not yet subscribed to the channel, please subscribe. Thank you very much.